Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome back to my channel. So today we'll be solving the chemistry SL paper 1 of the November 2024 attempt. So let's start. Yeah. So we have the first question here. How many moles of phosphate ions are present in 103.39 grams of Ca3PO4 whole twice? So Ca3PO4 whole twice, this will dissociate to form 3Ca2 plus and twice PO4 3 minus. Now moles of Ca3PO4 whole twice, this will be mass, which is 103.39 divided by 310.18. So 103 times 3 is approximately equal to 310, right? So you can approximate it to 1 by 3, right? Now, molar ratio of PO4 3 minus and Ca3PO4 whole twice is 2:1, right? So moles of PO4 3 minus, this is 2 times the moles of Ca3PO4 whole twice, which gives us 2/3. 2/3 is 0.67, which is option C. Moving on to the next part, we have to find the sum of coefficient of the balanced reaction. So let's start. In order to balance iron, I'll put a 2 here. To balance sulfur, I'll put a 2 here. Now on this side, I have 3 plus 4, 7 oxygens. To put 7 oxygen on the other side, I'll multiply O2 with 7/2. Okay. Now this is the balanced reaction. Now what happens is, to make it integer, I'll multiply both sides with 2. So I'll have 4 FeS plus 7 O2. Should give me twice Fe2O3 plus 4 SO2. So total sum is 4 plus 4, 8 plus 2, 10 plus 7 is 17. So question 2 should be D. Right? 4 plus 7 plus 2 plus 4, which is 17. Yeah. Next one, what is the yield of sodium chloride in grams when 2.3 grams of sodium reacts with 11.4 dm cube of chlorine gas? So first let's find the moles of sodium. Moles of sodium is 2.3 divided by molar mass of sodium is 23. This gives me 0.1. Moles of Cl2 will be 11.4 divided by 22.7. So 11.4 times 2 is 22.8. So this is approximately equal to half, or 0.5. Now we have to find N by Sc for Na, moles by stoichiometry coefficient. Moles is 0.1, stoichiometry coefficient of Na is 2. So this gives you 0.05. And N by Sc of Cl2, moles of Cl2 is 0.5, stoichiometry coefficient is 1, this is 0.1. So the compound with the smaller N by Sc will be my limiting reactant. So Na is the limiting reactant. Now we'll find the moles of NaCl. So Na to 2 Na gives you twice NaCl, right? So 2:2 is 1:1 ratio. So moles of moles of NaCl, this will be 1 times the moles of Na, which is equal to the moles of Na, 0.1. Now mass of NaCl will be this moles times the molar mass, which is 58.4, 5.84. Answer is B. Moving on to the next question. What's the pressure in Pascal in 3 dm cube cylinder containing 64 grams of O2 at 25 degrees Celsius? Now we can use these set of units. Pressure in pascals, volume in meter cube, with temperature in Kelvin. Then we can use R as 8.314. So PV equals nRT, right? So pressure will be nRT by V. Now moles. So N of O2 would be 64 divided by molar mass of oxygen is 16 times 2, which is 32, which is 2, right? So 2 times R is 8.314 temperature has to be in kelvins, right? So temperature would be 25 plus 273, which is 298. Okay, now the volume is 3 dm cubed, right, which is 3 times 10 to the power minus 3 meter cubed. So if I compared this thing, 2 times 8.01, so it exactly matches with option B. Answer to question 4 is B. Now for question 5, we have to find the relative atomic mass of the element, right? The relative atomic mass is summation of percentage abundance times mass or mass over charge divided by 100. So here generally charge is 1, so on the x-axis you have the masses of the isotopes, right? That is 80.1 times 10 plus 19.9 times 11 by 100. So 80.1 I can just round it off to 80, so 80 times 10 is 800. 19.9 I can round it off to 20, so 20 times 11 is 20 times 11 is 220 divided by 100. So this is 1020 by 100, which gives you 10.2, which is option B. Now moving on to question 6, we will find the correct wavelength and energy of UV and visible light. Now for this question, we can just use a general idea to solve this entire question. That is, ultraviolet rays causes cancer, right? And radiations which have higher energies are generally able to cause cancer. So of course, energy of like UV light should be greater than energy of visible light. Okay, energy of UV is greater than energy of visible, right? So we can eliminate option B. We can eliminate option D. Now, energy is inversely proportional to wavelength because E equals hc by lambda, right? So higher energy means lower wavelength, right? That is option A. So UV region has lower wavelength and higher energy. Visible region has higher wavelength and lower energy. Next, which statements are correct regarding the organization of elements on the periodic table? Okay, now let's start one by one. Elements with atomic number 4, 12, 20 have atoms with the same number of energy levels. That is actually not right. If you go up 4, 12 and 20, right? So this is 4, 12, 20. So 3 has 3 different energy levels. So BE, right, is in the second shell, right? So it has subshells 2s and 2p. The third one has 3s, 3p, 3d. Fourth one has 4s, 4p, 4d, 4f. So obviously the first one is incorrect. Elements with atomic number 9, 17, 35 have atoms with same number of electrons in outer shell. So let's check whether they are in the same group or not. 9, 17 and 35. 9, 17, 35. They're in the same group, group 17, right? So they have the same number of outer electrons. This is correct. Periodic table is divided into blocks based on sublevels occupied by electrons. This is correct because first two groups are S block, okay, then you have the D block elements, then on the extreme right you have the P block, right, and below the periodic table you have F block. So yeah, periodic table is divided into blocks based on sublevels. So 2 and 3 are correct, so answer should be C. Next one. Which of these period oxides form solution with pH less than 7 when added with water, right? pH less than 7 means it should give you an acidic solution. Okay, acidic solution is given by non-metallic oxides. Metallic oxides will give you a base. So eliminate B, I can eliminate C because these are metallic oxides. Al2O3 is amphoteric. Okay, so it will react like an acid with a base and it will react like a base with an acid. So answer is option D, which is Al4O6. Now question 9. What type of bond is formed between nitrogen and hydrogen when ammonia reacts with water? Basically, when ammonia reacts with water, this is the kind of reaction which we can expect. This lone pair will attack water and this bond will break. Right. So if you check, hydrogen when it leaves H2O does not carry any electron on it. Hydrogen has 0 electrons on it when it leaves H2O because oxygen gets both the electrons and oxygen forms OH minus ion. So both the electrons, so when a nitrogen hydrogen bond is formed, both the electrons will be shared by nitrogen. Right? This is a coordinate covalent bond or a dative bond. Fine. and as a result the answer will be C. Yeah. The next one, which type of intermolecular force exists between CH4, CH3OH and CH3Cl? In CH3OH, the structure looks like this. So hydrogen is directly attached to oxygen. So CH3OH will have all the intermolecular forces till hydrogen bonding. Right. So it will have London dispersion forces, hydrogen bonding, and dipole-dipole. I can eliminate options C and D based on this. CH4 will only have a London dispersion force because it's a non-polar molecule. Okay. So again, I can eliminate B. So answer is A. And for CH3Cl, it is a polar molecule, but it does not form hydrogen bonds because obviously you cannot say hydrogen getting attached to oxygen, nitrogen, or fluorine. So CH3Cl will have London dispersion forces and dipole-dipole forces. So that's all about question 10. Moving on to question 11. You have to find the molecular geometry of the numbered atoms in the molecule shown below. Okay. So first one is N. In N, basically, you have this is the setup around N, right? So you have 2 bond pairs and 1 lone pair, right? 2 bond pairs, 1 lone pair gives you a bent molecular geometry, because what happens is the electrons will repel, right, the bonds, and as a result it looks like this. So nitrogen bond will be bent, so I can eliminate option B and C from this information. Now if I check the second one in this carbon, there is a hydrogen, right, and there are 2 bonds. So when you have 3 bonds around an atom, right, it's trigonal planar. The bond angle is 120 degrees. So carbon 2 is trigonal planar, and from that we can say A is the right answer. And for the third one, you have just 2 bond pairs around this carbon, right? When you have 2 bond pairs, this bond angle is 180 degrees and the molecular geometry is linear. Done. Next. Which statement are correct for alloys? Okay, they are homogeneous mixture of metals with other metals or non-metals. This is correct. Yeah. Different sizes of atoms in alloys prevent layers of metallic cations sliding over each other. This is how, the strength of alloys are bigger than that of the metals. So second one is also correct. And adding carbon to iron produces an alloy that is stronger than pure iron. That is your steel. So 1, 2, 3, all of them are right. So answer should be option D. Now for the next one, which of the following reactions represent enthalpy of formation? In enthalpy of formation, 1 mole of product should be formed from elements in their standard states. So now here, if you look at the product side, all of them are 1 mole. So you have to check for elements where they're in standard states. Standard states are H2, Cl2, Br2, O2, N2, like that. Should be the singular element. The molecule should just have 1 type of atom. Okay. So here C2H4 HBr, this is not in standard state, so this is wrong. Al 3/2 H2 3/2 O2 gives you AlOH whole twice. This is the right answer. Yeah, this one CaOSO2 is not in standard state. H and O3, H and N are not in standard states. It is also wrong. Can be H2 and N2. Now the next one, this is a Hess law problem. We have to find the delta H of this reaction. We'll quickly use equation manipulation. C2H4 is on the left side. Here it's on the right side. So I'll flip the first reaction. C2H4 gives you 2C plus 2H2. Delta H after flipping would be negative Z. Next one, you have 2CF4. So CF4 is here, so I'll multiply the second reaction with 2. So 2C plus 4F2, it gives you twice CF4. Delta H is negative 2Y. And the first one, you have 4HF on the right side. Here on the first equation, 2HF is on the right side, so I'll multiply the first equation and add it. Now delta H again would be minus 2x. Now if I cancel carbon on both sides, hydrogen on both sides, and add everything up, you get C2H4 plus 6F2, giving you twice CF4 plus 4HF. Delta H will be minus 2x minus 2y minus z, which is option D. Now, for the next one, we have two diagrams where Maxwell-Boltzmann curves are plotted for T1 and T2. T1 is bigger than T2, right? Generally in problems we see T2 is bigger than T1, so here T1 is bigger than T2. So what happens is T1 will be flattened out. Peak of T1 will be lower than that of T2, and T1 will be a little bit flatter. So here T1 and T2 are at the same height. Wrong. T1 should be at a lower height. Again, T1, T2 on the same height, or T2 is bigger than T1 here, so this is wrong. Again, T1 is bigger than T2 for this one. Answer should be B. In B, you see T1, the peak is lower than that of T2, right? And the peak has shifted to the right. So the curve has flattened out. So B is the correct answer for question 15. Now for question 16, what's the standard enthalpy change when 107 grams of solid ammonium chloride added to water form a 50 centimeter cube solution producing maximum decrease of 28 degrees Celsius? Okay, so heat will be heat absorbed by water is equal to mc delta T, right? So you have 50 centimeter cube of solution. We have to assume that the density of density of this solution is equal to density of water. So the mass of water is 50 grams. So 50, C is 4.18, and temperature is the decrease in temperature, right? So minus degree 28 will be the delta T. Fine. You can just keep it like this, and then moles of NH4Cl. This is 107 divided by 53.5. So 53.5, 2 times 53.5 is 107. So this is 2. Delta H is negative Q over N. Use this formula. So negative of negative 50 times 4.18 times 28 divided by 2. Make them positive. So finally answer should be 50 times 4.18 times 28 by 2. Unit will be joules per mole. But here your answer has to be in kilojoules. So we will divide it with 1000. So comparing with the options, I think option D is the right answer. Yeah. Now moving on. Excess magnesium powder was added to the beaker of HCl. The mass of beaker and its contents were recorded, plotted against to give line 1. So initially you have this line 1, right? Now what change would give line 2? So line 2 has a lower rate of reaction. Okay, the reaction is slower and it's producing less products as compared to 1. Now let's check. Same volume of more diluted HCl. This can be correct, or this is actually right. Because thing is, if you have less moles of HCl or concentration of HCl is smaller, the rate will be lower. And HCl is the limiting reactant here. So as you are adding less moles of HCl, you'll get less products. If you look at part B, by using the same mass of magnesium ribbon, I don't think that will be right. Because magnesium ribbon, if you just keep it, you'll get the same final mass. Because HCl is the limiting reactant. Final mass will be dependent upon HCl, not Mg. This is wrong. Increasing temperature makes the reaction faster. Here it's becoming slower. Doubling the mass of powdered Mg, that will make the reaction faster. But the final amount of the final mass of the container, that will remain the same. Because again, final mass depends upon the limiting reactant. This is also wrong. Next one. Carbon dioxide dissolves in water as shown in the equation. What will happen when temperature is increased? So delta H is negative, right? Negative means in the forward direction heat is released. In the reverse reaction, heat is absorbed. Now when temperature is increased, okay, by Le-Chatelier's principle, reaction tries to decrease temperature. How can it decrease temperature? By absorbing heat. So the equilibrium will shift to the side where heat is absorbed. So equilibrium shifts to the left. If equilibrium shifts to the left, what happens is H3O plus concentration will decrease. If H3O plus concentration decreases, what happens is pH increases. Because pH is negative log base 10 H plus or H3O plus concentration. H3O plus concentration decreases, the log value increases. So that's why bases have higher pH as compared to acids. So equilibrium should shift to the left and pH increases should be the right answer. Yeah. Now the next one. pH of an aqueous solution Z is 5, pH of an aqueous solution X is 10. What's the ratio of the H3O plus concentrations? So H3O plus concentration of Z is 10 to the power minus 5. And H3O plus concentration of X is 10 to the power of minus 10. So H plus is 10 to the power of minus pH. Okay. Now we can just take this, take the ratio. Ten to the power minus 5 by 10 to the power of 10. So H3O plus of Z is 10 to the power 5 times H3O plus of X. Okay. So if you look at the options, H3O plus is 1 times 10 to the power 5 times lower in X as compared to Z. Answer should be D. Comes from this equation directly. Now the next one. Which of these has the weakest conjugate base? So the strongest acid will have the weakest conjugate base. So it's HCl. NaOH is a base, CH2CH2COH is a weak acid, so it will have the strongest conjugate base. And NaCl is a salt. Yeah. Which reaction does H2 act as an oxidizing agent? Okay, so we have to look for the oxidation number change in hydrogen. So here in the first reaction it's 0 and it's +1. So H2 is getting oxidized. If H2 is getting oxidized, it will act as a reducing agent. So first one, reducing agent. This is wrong. Second one, H2 has +1 oxidation, 0 oxidation state here. But in NaH, Na has +1, hydrogen has -1. So oxidation number of hydrogen decreases from 0 to -1. 0 to -1 means it's getting reduced. If it's getting reduced, it is the oxidizing agent. The answer is option B. Yeah. Now, for question 22, a voltaic cell is constructed from half cells containing metal X and Z as electrodes. Z is the more reactive metal. What will occur when the cell produces electricity? Right. So Z is more reactive, right? So Z will form Z2 plus and 2 electrons. And X2 plus will add 2 electrons to form X solid. Right? These are the two expected reactions from this voltaic cells, right? So what happens is, let's look into the options one by one. So electrons are generated here, right? And the electrons will flow from Z to X. So electrons flow from X to Z. This is incorrect, which is option B. Next, concentration of X2 plus increases, but we see that X2 plus concentration will decrease with time because X2 plus will react with 2 electrons to form Xc. With time, Xc will become fatter, but X2 plus concentration will decrease. I'll also eliminate option C. Now, positive ions flow from salt bridge to Z. In Z, in this part, Z2 plus ions are produced, right? To neutralize Z2 plus, negative ions will, let's not take X here. Negative ions, P minus. Negative ions will enter this Z2 plus solution to neutralize the positive charge. But positive charge from salt bridge will not enter the left electrode. Okay, A is also wrong. Mass of electrode Z decreases. That is correct because Z solid becomes Z2 plus, right? So with time, Z solid amount will keep decreasing and Z2 plus concentration will keep increasing. Answer is D for 22. 23. What happens when chlorine gas is bubbled through aqueous solution of sodium iodide? Okay, alright. Now, from the reactivity series, or if we just use the general rule that reactivity, chlorine has a greater reactivity as compared to iodine. So Cl than I. So Cl can displace iodine from its salt. So NaI plus Cl2, it should give you twice NaCl plus I2. Okay. So now if you look at it, there is no reaction. This is wrong. Chlorine is oxidized to chloride. It's not oxidized, it's reduced. Chlorine has an oxidation number 0. Chloride Cl minus has an oxidation number of -1. 0 to -1 is reduction, not oxidation. B is wrong. Oxidized to chlorate 5. So here chlorate 5 is not formed. Cl minus chloride is formed. A is wrong. Now the option C is correct exactly for this question, because I minus ions, 2I minus is becoming I2. So I minus ions, oxidation state -1, is getting changed to I2 with oxidation number of 0. -1 to 0 increase in oxidation number, so that is oxidation. Now the organic questions. Which products are formed when butene reacts separately with aqueous hydrogen bromide and bromine water? When it reacts with HBr, what happens is this bond breaks and hydrogen and Br are attached to, you can add hydrogen and add Br to any of the carbon atoms, right? So finally our structure will look like this. So this is X, CH3, CHBr, CH2, CH3. Okay, so if I look at it, it's CH3, CH2, CHBr, CH3, which is either this or this, right? So you can eliminate B and C. For Br2, basically, both carbon atoms will add one bromine. So this is, CH3, CHBr, CHBr, CH3, option A. This exactly matches with this formula. 24 would be A. Now moving on to 25, which of the following compounds can react with acidified K2 potassium dichromate K2Cr2O7 to give an acid, right? Acid, primary alcohols can be oxidized to form acids. Okay, the first one, this is a secondary alcohol. Max to max you can create a ketone if you oxidize it, but you cannot create a carboxylic acid. Part B is already a ketone, cannot be oxidized further. Let's take part D. Part D, if you check, you have three CH3 groups and OH. There is a tertiary alcohol. Tertiary alcohols cannot be oxidized, so we can eliminate ABC. I know answer has to be C, but why is it C? Let's try to understand the reasoning behind it. So CH3, CH2, C, CH2, OH, H, CH2, CH3. This is the compound. If I put K2Cr2O7, what happens is this is a primary alcohol. Okay, because this carbon is connected to one other carbon atom. As it's primary, if I put K2Cr2O7, it will get converted to carboxylic acid. That's it. Answer to 25 should be C. 26. How many structural isomers of alcohol with a molecular formula C4H9OH exists? Okay, let's try drawing them one by one. So first, 4 carbon atoms in a straight chain and OH on the first carbon. This is the first isomer or the basic structure. Then I can shift OH on the second carbon. So here, with 4 carbon atoms in the main chain, I can have 2 isomers. And then I can reduce the chain length by 1. Okay. Either I can place OH here or I can place OH here. So these are 2 different compounds. So 2 more isomers here. So in my understanding, 2 plus 2, 4. And I don't think we can produce any other isomers. If we try to do it, it will basically give us the same compounds, right? So answer should be C, which is 4. Now we have to find the IUPAC name of this compound. So for any of these, ball and stick diagrams, first we'll try to draw the compound. So CH3, CH2. This one done. Then this C is connected to CH. This is connected to one CH3. The other part is connected to this carbon, which is H. It's connected to another CH3 here. At the end, you have C double bond O H. This is the structure. Now we have to write the IUPAC name. Numbering should be done from right to left so that your functional group gets the lowest number. 5 carbon atoms is pent and the functional group is al. So at the end you should have pentanal. So C and D can be eliminated. Now the positions of the methyl groups is 2,3. So it's 2,3 dimethyl pentanol. So A is correct. B, the name is fine, but just instead of methyl, it should have been dimethyl. Okay. So 27 is A. Now moving on to 28. Which functional groups are present in aspartame? Now this functional group is called carboxyl. There's an NH2 group here. This is primary amino. This is an ester group. This group is called amide. And this is phenyl. Now let's check the option. Carboxyl secondary amino, ether, wrong. Carboxyl secondary amino, ester, wrong because it's primary amino. Ether primary amino, secondary amino, wrong. We don't have ether. Ester primary amino, carboxyl. This is correct. You have ester, you have primary amino, you have carboxyl. So 28 has to be option D. This is the correct one. 21. Which statements are correct about molecular ion M+ in a mass spectrum? Okay, alright. M+ is not always the peak with highest intensity in the mass spectrum. Yeah, the first one is correct. M+ might not have the highest intensity. Okay, but like highest intensity is the Y value, right? So it may not have the highest intensity, but it will have the highest X value. Okay. M+ is always the most stable fragment formed during electron bombardment. Not correct, because if M+ is stable, what happens is there won't be any further disintegrations. Right, and if M+ was stable, we'll always find that M+ would have the highest intensity. So that doesn't happen, so second one is wrong. Third one, M/C ratio of M+ ion gives the relative molecular mass of the molecule. This is also fine, because so 1 and 3 are correct, option B. Now the last one, student performs an experiment or investigation to determine the content of ethanoic acid and vinegar samples using non-standardized NaOH solution. Which type of error will occur and how will this affect the quality of data obtained? Now you are using a wrong concentration of NaOH. Okay, if you're using a wrong concentration of NaOH, what happens is this is a systematic error. Whatever times you repeat the titration, your accuracy or your final result will always be wrong. So it will have low accuracy and it's a systematic error. Answer is A. So with this we are done with paper 1 SL, and I'll soon be posting the paper 2 SL solutions. Thank you so much. See you in the next video.